ESA has released a new map showing the first light of the universe that challenges some of the fundamental principles of the Big Bang theory. This latest cosmic microwave background map from Planck, ESA's mission to investigate the origins of the universe, questions some of the concepts behind the basic theory of the expansion of the universe, commonly known as inflationary theory.
We see these strange patterns that are not expected, in inflationary theory, the simplest inflationary theories. It may be that we've been fooled, that inflation didn't happen.
What's surprising in Planck's latest findings, and is inconsistent with pervading theories, is the presence of unexpected large-scale anomalies in the sky, including a large cold region, stronger fluctuations in one half of the sky than the other, and less light signal than expected across the entire sky.
When you look only at the large features on this map, you find that our best fitting model, our best theory, has a problem fitting the data.
Planck, launched in 2009 by Ariane 5, is the third mission to study the cosmic microwave background to date. While these unusual features in the sky were hinted at in the two previous US missions, COBE and WMAP, Planck's ability to measure the tiniest of fluctuations in the cosmic microwave background has made these so-called anomalies impossible to ignore.
Because of these features that we're finding in the sky, people really are in a situation now where they cannot ignore them anymore. There have been hints of these things in the past, and they have been able to ignore them, but not anymore, because we've established them as facts.
With its extreme accuracy, Planck was expected to revolutionize our understanding of the birth, evolution, and ultimate fate of our universe. It's this very accuracy that may now make it necessary for scientists to rethink some of the underlying theories of how the universe began and how it's evolving.
By now, you can clearly see that the structures we find in space are easily explained by these bowl-shaped magnetic fields without using black holes, dark matter, or dark energy. It is important to note that these bowl-shaped magnetic fields will not always be nice, simple, symmetrical structures. They can be warped, twisted, offset, or one field might even be larger than the other as shown here. But once you understand the basics of this new theory of matter formation due to bowl-shaped magnetic fields, you will be able to easily explain most all of the structures we find in space.
The nature of the photon, the carrier of the light, is such that a fast-moving light source doesn't actually alter the color of the light. This fact is easily recognizable. The color of light is determined by the energy environment within the electromagnetic photon envelope when the light is created. Some photon packets are larger, some are smaller. The higher the energy level is inside a photon package, the tighter the package is held together, and the smaller it thereby becomes. The physical movement of an atomic element in which the photon package is formed does not affect the size of the package. Only the energy level within the atom affects the size of the photon and thereby its color. Different size photons are recognized as different colors. This fundamental pattern, of course, extends far beyond the visible spectrum, which is actually quite narrow. Extremely high energy levels, for example, produce extremely tiny packets, such as the X-ray photons that are typically 100,000 times smaller than the photons of visible light. But why won't light change its color once it is created? Let's take a look at this. When one throws an apple out of the window of a fast-moving train, the apple doesn't end up being stretched out before it impacts the ground. This is so because an apple is an entity, regardless of the speed of the train that carries it. However, a different principle applies to sound waves. When a fast train drives through a station, its whistle is of a higher pitch when it approaches the station, and of a lower pitch when it moves away from the station. This is so because a sound wave is a disturbance in the air that reaches an observer's ear at a different rate by approaching or departing. In sound, the shifting pitch is normal because sound is a disturbance in the air, while light is not a disturbance but is an individual object, a discrete package. A beam of light is a propagated stream of individual entities. However, because light consists of photons that are complete individual entities that are of a specific size for a specific color, and the size of the photon is determined by the energy it contains, the size can change when its energy is dissipated on the path of its travel over extremely long distances. This factor is significant in the context of the Big Bang redshift theory. The redshift that is observed in light from distant galaxies is, of course, totally real. We see the spectral lines received from different galaxies. We see them shifted collectively towards the red. But how is the redshift possible when light is made up of discrete photon entities that cannot be stretched out in the same manner as a disturbance would be stretched by a receding source? The answer is simple. When light is propagated over very long distances in the range of hundreds of millions of light years, a slight energy depletion occurs along the way. The photon package increases in size by the energy depletion. The purple light thereby becomes blue light. It becomes a larger package, and the blue light becomes green light, and the green light becomes yellow light, and so on. The entire spectrum of the light becomes shifted towards the red. And the red, of course, gets shifted off the visible spectrum.
It means that every individual wave is not 100% stable. Every wave, in fact, is always losing energy because the nonlinearity means that the wave shape is always changing. And this energy loss goes to harmonics of the wave. We see this in a particular example of this is when a wave is breaking near the seashore. A wave that's travelled with a more or less sine-shaped wave, when it arrives near the seashore and the shore and the water gets less deep, the tops of the waves now travel faster than the bottoms of the waves, and they overtake them and the wave breaks. And this complicated thing that happens when the wave breaks is something akin to what's going on near the centres of particles, where a more complicated thing goes on and energy is lost to harmonics, and other frequencies are given off or created within that particle. And this is how the whole universe arises, from this non-linearity, and this is what will be dealt with in part 3.
Nature has not two different ways of creating anything. Created only by waves. There is nothing in the nature but waves of motion. Waves multiply in the direction of their amplitude, and they divide on the way down, back to silence of the zero from which it came. That's life and death. And the resurrection on the other side of the equator, when the same A note of the offspring reproduces itself again as another A note. They're so fast we think of them as continuous, because they're so fast. But there's a black gap of silence between each one of those. Every time it passes the zero point plane of silence from which it has appeared, it's silent again. Then it appears on the other side. The same siren sounds accumulate, multiply into the A tone of that you're after. So it is they're so fast we think of them as continuous, because they're so fast. But there's a black gap of silence between each one of those. Every time it passes the zero point plane of silence from which it has appeared, it's silent again. And it appears on the other side. The same siren sounds accumulate, multiply into the A tone of that you're after. So it is And another question, what is the secret of the 30 octaves between sound and light? 30 octaves between sound and light. Science? The science thing? You go ask them. I don't know. There is no such thing. There is no such thing. There aren't any octaves in nature in excess of the 9 octaves of nature. And between light and sound, they're the same things. The light is produced by compression, and it's at the maximum of its wave, it produces a sphere. And sound is produced in the same way, by producing a wave vibration. And at the amplitude, you produce the sound that is desired. No other place upon it, except at just one little point on the wire that is vibrating over violin string or harp. Just one point that you hear the completed sound. All the way up to that you hear a siren sort of growing up to it. If you could delay that sound instead of hearing it in a thousandth of a second, if you could spread it out over a minute, you'd hear just this sound siren growing till suddenly the keynote, the A or the B or the C note is produced. So, point of plane of silence from which it has appeared, it's silent again, and it appears on the other side. The same siren sounds accumulate, multiply into the A tone that you are after.
Now the redshift phenomenon makes sense. It has nothing to do with light from distant galaxies being stretched by a moving light source that is racing away from us. The entire Big Bang Theory thereby falls apart.
This is a spiral galaxy, one of hundreds of billions of galaxies in our universe. It consists of over 100 billion gravitationally interacting stars, which form a complex rotating system. Let's look at the rotational velocity of the individual regions of the galaxy in more detail. Starting in the center of rotation of the galaxy, the graph representing the rotational velocity of the galaxy initially increases steeply with every greater distance from the center of rotation. However, at a specific distance, the graph levels off and remains almost constant. Naive had assumed that the rotational velocity would fall off according to Kepler's third law. However, Kepler's third law describes the orbital velocity of planets orbiting a single star. It was claimed that the discrepancy between the two graphs would cause the stars on the fringes of the galaxy to be catapulted away by the centrifugal force. Therefore, the existence of a dark matter was postulated that is supposed to prevent the galaxy from breaking apart. This dark matter is believed to comprise about 24% of the total energy of the universe. However, dark matter is a myth. Why? Let's look a bit closer at the planetary motion in our solar system. In 1618, Johannes Kepler described the orbital velocity of planets orbiting the Sun with his third law of planetary motion. It is important to know that the Sun contains about 99.9% of total mass of the solar system. As you can notice easily, Mercury, the closest planet to the Sun, has the highest orbital velocity of all planets. The other planets demonstrate increasingly lower orbital velocities the further they are away from the Sun. This results in a velocity curve that was naively applied to the rotational dynamics of galaxies. However, there is a huge problem. The orbital dynamics of planets orbiting a single star can in no way be compared to the complex rotational dynamics of a galaxy comprising hundreds of billions of stars. Before describing rotational dynamics of a galaxy, let us first consider a spinning top. A spinning top is a rigid body. When looking at individual points on the surface of the spinning top, we notice that the rotational velocity at different points increases the further away the marked points are from the center of rotation. Graphically, this corresponds to an increasing linear graph. In contrast to a planetary system in which 99.9% of the total mass of the system is concentrated in a single star, a galaxy consists of over 100 billion individual stars, forming a complex gravitationally interacting rotating system. Thus, the rotational dynamics of a galaxy is not at all comparable with the orbital dynamics of a planetary system. Close to the center of the galaxy, the rotational velocity of the galaxy behaves due to the high star density, like a rotating rigid body, just like our spinning top. Beyond a certain distance, the star density decreases greatly. Therefore, The rotational characteristics of a galaxy are a combination of the rotational dynamics of the rotating rigid body and the orbital dynamics of the planets. The actually observed rotational dynamics of galaxies guarantees their stable rotation. Dark matter is therefore a fairy tale, a mysterious chimera that is easily refutable through the application of physical laws. However, astronomers insist that the dark matter chimera makes up 24% of the total energy of the universe. Another 71.4% of the total energy of the universe is attributed to another elusive energy known as dark energy. According to current consensus, the observable, verifiable universe only makes up a pitiful 4.6% of the total energy content of the universe. Dark energy, which cycles the supposed qualities of expansion of the universe, is likewise pure fantasy, and a miserable attempt to make the cosmos an esoteric playground. Learn more about this topic in the book Einstein's Universe, without Big Bang, and the solution of Hawking's Paradox.